The body's immune system is a truly remarkable piece of engineering, and it has many, many different moving parts. And I just want to talk a bit about what we're concerned with, which is the B cell receptors or antibodies. So in your blood, you can produce B cells of many different B cell receptor varieties. So the B cells, um, when they grow from your blood stem cells, they mutate and take on many different forms for their B cell receptors. And some of those forms can bind to a pathogen and some of them can't. B cells which can bind to the pathogen incorporate it and chop it up, and then T cells find these pathogen pieces on the B cell um, on the B cell's surface, and they tell the B cell that, okay, yeah, you're a good binder, you can replicate and generate more B cells. So the B cells start replicating. So as the B cells are replicating, they gain mutations, and these mutations can change the form of the B cell receptor, and sometimes that actually increases the binding affinity of the B cell receptor to the pathogen. And then these better binding B cells will get upregulated by the T cells and start to reproduce. So this process of continual refinement is what's called affinity maturation, and it's this evolution process where B cells with better binding are selected for, and B cells with less good binding don't replicate. This process can take a long time, um, especially when the pathogen has a lot of different forms. And so what people have done is they've taken the B cell receptor code, and they've taken it and they put it into cancer, specifically Chinese hamster ovarian cancer. And this ovarian cancer is super upregulated, and it will just produce tons of B cell receptor. And then you can isolate and harvest this B cell receptor, inject it into a person who is infected with the virus, and that provides some protection against the virus. But there's a problem, and the problem is that the virus can mutate. So if the virus mutates and one of these mutated varieties is resistant to the antibody, then it won't be bound, and it will be free to go on and infect a new cell. So if this is HIV, it will go and find a T cell to infect, and then it will be able to reproduce and get the person sick again.